UK, Toronto, Philippines, Bangalore. Yes. Oh, love it. I love it. We're getting plenty of folks from all of Ethiopia, India, Brazil. Outstanding. Welcome, everybody. My name is Michael Lin. I'm a developer advocate at MongoDB, and I'm super excited for you to be joining. We're going to talk about data modeling today. And it's just about 1 after. I'm going to wait until 2 minutes after. We'll get the presentation started. And we're going to talk about data modeling today. I'm wondering how many people are joining with absolutely zero knowledge of MongoDB? Who's got no knowledge of MongoDB at all? Anybody? We're going to get you up to speed. Zero knowledge. Okay, great. Brandon, welcome. It's great to have you here. So I'll keep that in mind as we go through the presentation. I'm going to try and give you some basics about MongoDB. We're going to think about how you would model your data for an application that uses MongoDB on the back end. And we'll try and take into consideration the range of folks that understand MongoDB. We're going to have questions. We're going to have the ability to ask questions. Please use the Q&A box for that rather than the chat. Everybody's piling into the chat now. There is a special space for questions. Okay? So make sure you use that if you want to get your questions answered. My good friend, Jesse Hall, Code Stacker, is joining me. He's going to be helping out answering questions. Let's get things started. Once again, my name is Michael Lin. I'm a developer advocate at MongoDB, and I also run the podcast. I would love for you to check out the podcast. We've got some great guests this week. We've got Bianca Lisli and Jakub Lazinski. They're talking about the Atlas CLI. So if you want to learn about the MongoDB Atlas CLI, check out the MongoDB podcast this week. And the rest of the 127 episodes that are out there on the podcast. You can follow me on Twitter. You can find me at mlin. I talk about MongoDB mostly on Twitter, but definitely give me a follow and check me out there. You can hit me up. Some housekeeping. This webinar will be recorded and shared on Friday. You're going to get an email. If you're registered, obviously, you've got to be registered to be here. You'll get an email with a link to the presentation. You will all be muted. I won't be able to hear you. So please use the Q&A box to get your questions answered. And then there's going to be a short survey that I'm going to ask you to start filling that out. The name of the podcast is MongoDB Podcast. You can find it on all podcast networks, wherever you get your podcasts. It's called the MongoDB Podcast. Thanks for the question, Brave. Okay, so there's going to be a short survey. So we're going to jump into that 15 minutes before the end. This is our agenda. We're going to talk about document data model. We're going to talk about MongoDB Compass, which is the user interface that you install on your laptop or desktop computer. Talk about modeling data with documents. We're going to talk about some common design patterns and anti-patterns, and then we'll talk briefly about the Schema advisor that's available in MongoDB Atlas. If you take nothing away from this webinar, please remember this one thing, very important. Here we go. Data that is accessed together should be stored together. If you remember nothing else about modeling data with MongoDB, and you remember that only, I'll be happy. I'll have done my job. Data that is accessed together should be stored together. That is very important when we think about modeling data. Come with me on a journey back to 1970s. 1970s. Many of you may not have been alive back in the 1970s, but I was, and this is what we looked like. This is how I used to dress as a kid, as a toddler. There was this guy. His name was Edgar Codd, super bright guy, and he worked for a company called IBM, International Business Machines. He worked on computers that looked something like this. Pretty crazy. Disk drives looked like this. I'm not kidding. That's huge, right? And these were super expensive. These disk drives were so expensive, they cost piles and piles of money. 1 megabyte cost about $9,200. That's insane, right? To give you a frame of reference, today, that same 1 megabyte costs about 0.00002 cents. So things were different back then. But this guy, Edgar Codd, super bright, like I said, he designed a mechanism, a methodology for laying out data that would maximize efficiency for data storage on the hardware of that time. And as I said, disk drives were super expensive. So he developed this methodology, and it's called Codd's Rules of Normalization. Many of you may have heard it, especially if you're designing databases and developing applications with relational database backends. Super important. And what these rules that he developed were designed to maximize efficiency for the disk drive so that you weren't wasting disk drive space. But that was around about 1970 when Edgar got busy on that rule, on those rules of normalization. And today, getting closer to today, 2007, they started thinking about developing MongoDB, and it's a different climate then. There's differences in the amount, in the cost for disk drive. So as I said, it was $9,200 per megabyte way back when, and it's something like zero these days. The other difference in the way that data is laid out, when you think about how data is laid out in a relational database, if you were to store a car in the same manner that you store data in a relational database, you might have maybe a table for your tires and a table for the seats and a table for the engine parts. And when you wanted to drive your car, you would have to pull that data out and join it all back together. And I want you to have this kind of the picture in your mind where within MongoDB, we store data in its natural state, all together, all referenced together. And again, that goes back to the methodology. Data that will be accessed together should be stored together. So it is a shift in the approach. It's a shift in the way that we're thinking about our applications. And we think application first rather than schema and data first. Okay, so in the tabular data model, we call that the relational model, you are forced to, out of the gate, create this structure that separates those elements of data and lays them out in separate tables. With MongoDB, we think in documents. We think about data in terms of the application and how the application will access the data first. And this is a document data model. And you can also call it a non-tabular model. Now, I'm going to be referencing some data elements, and it might be helpful for you if you wanted to jump in and play along at home. You can register for a free account at mongodb.com, cloud.mongodb.com. And are we having audio issues? Hey, I just want to stop and ask my colleagues, are we okay with the sound? Yes, and this will be recorded. Okay, good. Hey, thanks for responding. So some people can hear me fine. Okay, so you can register for a free account at cloud.mongodb.com. Once you log in, you can launch a free cluster. It's free forever. There's no tricks here. It's not like an expiring thing where you can play with it for a little bit and it goes away. It's free forever. And you get a limited amount of disk space, but it's enough for you to find out how MongoDB works. And again, that's cloud.mongodb.com. We are going to be looking at some sample data sets. I love the fact that we give you some sample data sets in MongoDB Atlas because it gives you a great peek into how some different document models are laid out. So if you want to look at those, you can load the sample data sets from within MongoDB Atlas. Once you launch your cluster, you're going to see an ellipsis right in the main screen for Atlas. You hit that ellipsis and there'll be an option for loading the sample data set. That's going to be about 350 megabytes of your 500 total. So it does take up some space, but it does give you some great sample data sets if you want to play with it, figure out how it all works. So go ahead and load that. It's going to take about 7 to 10 minutes to load, depending on your network speed, etc. Let's take a closer look at the documents that we've been talking about. Now, if you're coming to us from the world of relational database management systems, you may be used to looking at data in rows and columns in tables. We're talking about MongoDB, a document database, and this is an example of a document. Now, I want to call out some things that exist in this document. Okay, so this is one document in the database, and it's actually one of the sample documents from our sample mflix. These are key value pairs. Now, in a document model, the keys will always be string. That's why they're wrapped in quotes. The values, a key value, the values will be different types of data. Now, you see the first one is an object ID. That's because we store that in bsign. We store that in a binary representation. So let's put that to the side for a moment. Every document should have an ID. That's a freebie. Out of the box, you get an object ID, and that makes sure that the IDs are unique. So looking further at the key value pairs, we have title is, think of that like the column header, and then the value is the Lord of the Rings. That's a string. The next key value pair Again, we have the year is the string identifier for this field, and the value is 2003. That's an integer. There's no string, there's no quotes around that. Here's where it gets interesting. We've got other data types, and this is where we differentiate from the relational world. Look at countries, the country field. We've got a bracket here. This is indicating that the value type for the field countries is an array. Okay, so this bracket is indicating that it's an array of strings. So that's one way it differs. It's difficult to represent that in a relational database management system, but we also have documents. This is called an embedded or sub-document. For ratings, for the ratings field, we have this curly brace, which is the same brace as this starting indicator for the document. And the ratings field is an embedded document. It's got key value pairs embedded in it. This is referred to as embedding, and we're going to talk more about this because it is a key differentiator between relational or tabular systems and non-tabular systems. Now look at cast. For the cast, this is an interesting field because it is an array, like I mentioned, for countries, but it's also embedded documents. So this is how we differ. And this is the way that we can embed and make sure that the data that we're going to access regularly is all stored in the same place. We use embedding to do that. That's kind of cool. I want to show you what this looks like using the MongoDB Compass graphical user interface. Now, you're going to have to install this, and I don't know if Jesse, if you can put the link to that. I forgot to get that ahead of time, but there is a link off of mongodb.com/downloads for Compass, which is a software, an application that you install on your laptop or desktop, and it's going to give you access to your data in MongoDB Atlas or even local. Now, I've already connected to my database. I've connected to my cluster, and I have my databases, my sample databases that are stored here. And here I can go and find the sample_mflix, which is the database that we're kind of looking at throughout these examples. And let's go back to databases, sample_mflix. Where are we? Here we are. And I want to go to the movies collection. And here are the documents within the movies collection. Now, it kind of rolls them up so that they're easy to look at, but check out awards. This is an embedded document or an object with some key value pairs within it. So the first great thing about Compass is that it gives you the ability to view your data in MongoDB. It also gives you the ability to look at the schema. Now, when I click the schema tab for the first time in MongoDB Compass, I can click the Analyze Schema. And what it's going to do is it's going to look at the key value pairs in my database, in my collection, and decide the best way to show the data. So rather than the individual documents, it's showing bar graphs for those range data elements. So this is a great way for you to visualize your schema. The other thing you can do is within MongoDB, when you're querying MongoDB, you can develop MongoDB queries. MongoDB queries. And part of the MongoDB query language is the aggregation framework. Okay? So an example of an aggregation would be, let's say I want to filter, I want to match a certain set of documents in my database. So I would come down to this aggregation pipeline, and very similar to the way, if you're familiar with pipelines in the command line, in Unix, for example, I can take the output of one command and pipe it into the input of the next. That's the way aggregations work. And within MongoDB Compass, it's actually visually walking you through building those pipelines. So here I could develop a query that matches a certain set of fields. I can say, I think I had one in here already. Let's see. Where is my, here's an aggregation that I previously built. So in this query, I'm matching documents that have a year field, and I'm specifying that I want the year field to equal greater than 2010. And to the right, I see the output for the $match. The $match is my operator, and this is the output for this specific query. Now I'm taking the output of that and I'm passing it to the next stage. And there's many different operators that you can select. You can actually do searching, search meta, you can sort, you can skip, but I'm passing it to another match phase. And I'm specifying that I want only those documents that have a Metacritic field of greater than 90. So here, with these two pipeline stages, I'm saying I want movies that are newer than 2010 and have a Metacritic rating of greater than 90. Okay, so this is a way that you can visually build your queries within MongoDB Compass. Just a quick look at that. You also have the ability to do an explain plan. This is a concept that you'll find familiar if you're coming to us from the relational database world. Indexes work the same way in MongoDB. You're going to want to be able to explain how those indexes are working. This is a call scan, collection scan. Those are not generally good. If you're scanning your entire collection of documents, you're going to want to probably add an index, and explain plan will show you how effective the indexes that you created are. Speaking of indexes, you can create them visually with MongoDB Compass, clicking the create index, specifying the index name, new index, and then specifying the fields that you want to include in that. So let's say if we wanted to create a title, an index on the title, and ascending order, we could create that. That way, instead of scanning all documents every time we query on title, we would be able to leverage that index and access the data much more efficiently. All right, so I think I'm going to end the MongoDB Compass tour from this
stored on the cloud,
and we'll go back to our presentation.
It's free
okay,
too.
so we looked at the document data model. Let's think a little bit about our application in terms of the data model. So when we start developing an application with the document data model in mind, we're going to reference some questions. We're going to think about what our app is doing. What is our app going to do with the data that we're going to reference? And what does that data look like? Is it name data, user data? Is it customer orders? We're going to want to think about the key value pairs that we're going to create for our application. The next thing we're going to want to think about is the tooling. What type of tooling are we going to use? Will we be using a driver, for example? What language are we going to use to develop our application? Python, Node.js, Rust, all of these application programming languages are supported with MongoDB. And in order to use those, you would leverage a driver. You can also leverage the data API. It's available in Atlas. And then lastly, you're going to think about some proven design patterns. Fortunately, the MongoDB database has been around for quite some time, and there's been a lot of folks developing applications against MongoDB. And the great folks that have been doing this at MongoDB have put together some proven design patterns. So you don't have to go alone. You don't have to start out from scratch and figure out how to lay out your data. There's some proven design patterns that will help you. Now, we're going to use some language when we think about data modeling with MongoDB. And I want you to get used to these terms. The first is polymorphism. It's a big word. We break it down into its Latin forms. The poly simply means many, and morph simply means shape. So many shapes. Why are we talking about many shapes? Well, in MongoDB, a key concept for laying out documents, and this differs from tabular structures, you can have different shaped documents. And when I say different shapes, I mean different structures of key value pairs from one document in a collection to the next document in the collection. One document may have 5 key value pairs, and the next document in the same collection may have 6 to 10, whatever. MongoDB doesn't care. And that's different than the tabular world because it's very difficult to have a different number of cells in a table, right? You just can't do that. So polymorphism, difficult to say, easy to understand, is a key concept in MongoDB. The second concept that I want you to think about is, and we've touched on this briefly before, is embedding. So we're talking about embedding documents within documents and possibly even within documents again. And if you think about an example of this is like customer orders. Rather than creating 2 tables where you have an orders table and a customer table and you link or reference between them, you can embed. And why would we do that? We would do that so that we can access the data that is frequently accessed together. We can store the data that is accessed together all in the same place, okay? And we do that for efficiency. How are we doing on time? Okay, 20 minutes. All right, the next key concept is referencing. Now, this is the opposite of embedding. You're going to make a choice. When you develop your schema for MongoDB, when you model your data, you're going to choose between embedding data elements that have a relationship between them, or you're going to create a referencing structure. And this is most like what you're used to if you're coming to MongoDB from a relational database management system. Referencing is a key component of COD's rules of normalization. Okay, and it's not a horrible thing. We're going to talk about when that makes sense going forward. So here's the example: customers and orders. As I mentioned before, perhaps you're not accessing orders at the same time you're accessing customer data. You may want to store them separately and create a referencing structure between them. We'll talk about how to do that. And the last concept is performance. Every application developer, regardless of how long you've been doing it, you should be thinking about performance. You should be thinking about the decisions you can make to ensure that the performance that your application has is acceptable for the users. Now, many applications are not sensitive to performance, but you should always be thinking about performance. Okay, so there's some additional information around these key concepts. MongoDB implements a flexible document structure. We call this the document data model. And we favor an embedded data model where possible. Now, you can normalize data, creating a system of references, but you don't have to. It's not a mandatory thing as it is in the relational world. Data that is accessed together should be stored together. That's our mantra. I hope you guys are beginning to remember this. And then I want you to focus on how your application will use the data rather than saving money on disk space, okay? Data that is accessed together should be stored together. I hope this is, we're driving this home. Okay, so we've got questions coming in. We'll get to those shortly, folks. Let's talk about modeling relationships. There are some common relationship patterns in all data elements. These relationships exist regardless of whether or not you model the data. But as you begin to develop an application, you're going to have to model that data in some way. And you'll need to look at the relationships between the data elements in your application. The first is, oh wait, I want to talk about the actual data that we're going to use as this example. So in the sample data, sample Mflix data, we've got movies. And if you think about it, if you think about an application, you might see this in IMDb or somewhere similar, where you've got the movie title, you've got a rating, you've got runtime, you've got genres. Think about this data in the same way that I propose those questions that you ask about your application. What does this data look like? How will it be accessed? And what structures and relationships are there between the data elements? Okay. Here in some of these, we've got natural array structures like genres. You're going to have an array of genres. You're going to probably have a single director. Maybe there are multiple. I don't know. And then for writers, you're probably going to have multiple of those. You may want to think about an array. So this is the document data model for a movie database that we're working with. Now, if we want to model relationships in some of that data, and let's say that we're looking at a very simple one-to-one relationship between the movie data and the movie details. In the relational world, when you're developing an application like this that's got movie data, you're most likely going to have to create multiple tables. A movies table for the basic elements and a movie details table for the specific extended details about the movie. Now, in MongoDB, if we're modeling this data, you can do the very same thing. You can create two collections. They're not called tables in MongoDB, they're called collections. Create two collections, a movies collection and a movies details collection. And notice how we're creating a reference model between these two collections. We've got, in our secondary table, the movie details collection, we've got a movie ID, which is referencing the object ID back over in our primary table. You can do that with MongoDB. If you want to normalize your data in this way, you absolutely can. But you can also use an embedding model. And this is the most simple model of embedding a one-to-one relationship. We've taken that secondary data director and we've embedded it in the movie collection, not creating a separate collection, embedding it. When would we want to do that? When would we want to make the decision to embed rather than create a reference model? Well, you're going to want to look at the number of times that the director element is referenced at the same time as the title and the runtime and the other data elements. And 9 times out of 10, it's most likely going to be accessed at the same time. So why not embed it? Why not embed it? Let's take a look at the next modeling relationship. Well, thank you, Bruce. Appreciate that. Modeling one-to-many relationships. Modeling one data element when multiple data elements are related to that primary. And we can see this in a relational model where we have 2 tables. Again, we've normalized our data. The first table is our movies data. The second is our cast table. We're going to have multiple cast members. So we've got one movie and multiple cast members. If we were doing this with a relational model, you would want to create 2 tables, a cast table and a movies table, and reference the ID. So look on the cast table, we're back referencing to our primary table. Now, if you wanted to do this with the MongoDB document data model, we can support that. You can have multiple collections, and here we are creating a movie ID field. Okay, this is an arbitrary name that you pick, but the value is pointing back to the primary table. Okay, again, so this is a reference model, modeling one-to-many relationships in MongoDB. If you want to, and if it makes sense from an application perspective, from the performance considerations, then you can do this. But you can also, you have the flexibility to create a different way to model this very same data. Here we have the very same data in, excuse me, in an embedded version of this relationship. One-to-many relationship where the primary set of data, ID, title, is embedded in the same document as the cast. Okay, we're referencing this, we're modeling this data with an array of, sorry, I hit the key there, with an array of documents. So we've got an array cast with a set of embedded documents or documents within documents for the actors in that cast field. Okay, so that's how you might model one-to-many relationships in an embedded way. The final relationship set I want to mention is many-to-many. What if you've got many data elements that are related to many other data elements? And if you think about an example here, you might have a movie that is shot on location. And in order to indicate what movies are shot on what location, you may create a reference table that has the many-to-many elements modeled out. So in the relational world, you would model this with 3 tables. You would have your primary movies table, your locations table that exists independently of the movies, and then you would have a reference table with movie locations. And you would indicate a reference to the movie ID and a reference to the location ID to indicate that these 2 are related. This is modeling a many-to-many relationship. And you can certainly do the same thing with MongoDB's document data model. And actually, you can do it with two collections, the first being the primary movies collection, and then a locations collection, and create, in the primary document, filming locations and reference those locations. That's one way of doing it. There's another way of doing it. You can back reference in the locations. So listing a back reference in the locations collection to the movies, okay? And there's a final way that you can do this by creating an extended array of documents all in one place. So here we have one collection and we've got an attribute or a field name called filming locations for this specific movie, indicating that the country and location where this film was shot, the locations. Now, there are some implications here. If you're modeling in this fashion, in an embedded way, you will have multiple references to countries that are not that are related directly to the movie. You may have, let's say you have a change to the name of the location. You may have to make that in multiple places. But the great thing about this is that you get to make that decision as the application developer. Let's look at some rules of thumb for embedding versus referencing. With embedding, there's going to be a single query. When you embed efficiently, there's going to be a single query to receive all of the data that you need. You can have a single operation for deleting or updating the data. If it's all in one place, it's just going to be a single operation. Now, what it does mean, and as I just referenced, you will have data duplication. So it's going to be up to you as the application developer to make sure that you handle that data duplication effectively. The other consideration is that when you embed, you may end up with very large documents. And MongoDB, this is an outside chance here, but MongoDB has an upper limit on the size of documents. And it is 16 megabytes. That's a large document size. You probably never want to get close to a 16 megabyte document size, but it is a consideration when you're embedding, okay? Considerations for referencing. There will be no duplication of data, okay? In alignment with God's rules of normalization, you can create a schema where you're not duplicating data, where you're referencing multiple elements across multiple collections. You will likely have smaller documents. You'll have more of them, but you'll have smaller documents. And in order to access this data, this is really key, you will need to join the data, okay? So if you're creating multiple collections and referencing in a relationship, you're creating a reference model, you will need to create a join to bring that data back together, okay? And we use the lookup operator for that. Okay, so embedding, data is accessed together, okay? It is typically faster for reads, and although there's probably an outside chance that it'll be slower for writes because of the larger document size. With referencing, data that is infrequently accessed together, we're going to use this reference model, and there's a chance of faster writes because the documents are smaller. Now, it will be slower on reads because you're having to do multiple operations to get the same data. If you've got multiple collections storing the individual documents, you have to join them. So that's multiple reads. And again, chance of slower reads. Now, anybody want to take a guess at the default preference for MongoDB? You can slam it into the chat if you want to. Drum roll, please. Should be no surprise. Yep, there we go. Embedding. You guys all get this. So you guys are all tracking with me. The default preference for MongoDB is embedding. Bravo. Nice work. Now, once you design your relationship, once you model your data, you create your schema, and you begin writing your code, guess what happens? Your data is going to evolve. You're going to make some decisions about the evolution of your application, right? Rarely do we ever create a schema and have it set in stone forever. I've never written an application where I didn't have to change the model. Day one of my application, I may be capturing usernames, and I may have really thought about this and thought, man, it's really smart for me to just have one field for the name. Day one. Well, day two comes along, and I'm like, that was dumb. Why did you do that? Why don't you have the first name and the family name? You need that. So now I want to evolve my data model. So what happens with MongoDB? Oh dear. Day one, I've written all these users, all these documents. What happens? What happens? Well, MongoDB supports polymorphism. So day two, I can begin writing additional documents into my users collection that have a different structure. Anybody want to take a guess at what happens to the documents that were written on day one? Do they automatically change? Nothing. Nothing happens to them. They sit there. So you are going to want to think about this ahead of time, and perhaps you can create a versioning schema. You're going to want to include a version tag. So in your application, you can as you write your documents out, you can include a version tag. And I've chosen version as the name of the field, but you can call it ver, you can call it v, whatever you want to. It's going to be up to you to choose that. And as you write the data out and as you modify your application is going to have a version tag, right? You're going to store it in some source code repository like Git or something like that. You're going to want to evolve your data model and make sure that you tag the data model. That way you can go back and change it if you want to. You can go back and update those version 1 documents and change them to a more complete or up-to-date version. You may be thinking, when I first learned this, I remember the moment it came to me like, wow, this is great. Polymorphism is awesome, but how do I validate the data elements? Well, MongoDB has thought about that too. And they give you the ability to create JSON schema. JSON schema is brilliant. It can give you the ability to validate at various times in the lifecycle of the document whether or not you actually accept the data. Okay, so it's validated on insert or update, and it has to conform to the defined schema that you pass to it. So you do this on the create collection operation. So over here on the right, we've got db.create collection. We're creating a collection called movies, and we're specifying a validator, okay? And you're telling it what the valid structures of data look like for this particular collection. Okay, there's various levels of enforceability. You can set validation levels and validation actions. So you can reject the update or the insert if it doesn't match the certain, the predefined schema, or you can just warn on it. You can just send a warning back to the application. So that's up to you. You get that choice as the application developer. So moving right along, let's talk about some common design patterns, okay, when we're modeling data. Now, there are some really great patterns that have already been documented. And I'm going to get your pencils and pens ready. We're going to talk about those, and we're going to send you some details about where you can read more about these. Some great, really smart folks at MongoDB have thought very long and hard about all of the different design patterns. The approximation design pattern, the attribute, the bucket, the computed, the polymorphic design pattern. These have all been thought out and well documented, and we're going to give you in a moment a link to a blog, a series of blog articles where we talk about these. So let's take a look at the outlier pattern. One pattern. We can't go through them all, but we'll give you links to the document there at the bottom, mongodb.com/blog/post/building with patterns outlier pattern. There's all of the patterns are documented, by the way, not just the outlier. But if you think about a book application, okay? My brother, smart guy, much smarter than me, John. He wrote a book. He wrote one of the first books on the MongoDB aggregation framework. It's what got me interested in MongoDB. It's why I have my job at MongoDB. So my brother John wrote this book, and he sold 3 copies of it. Okay, so very easily he's storing in a field called customers purchased users, a string of the elements. Every user that buys the book gets stored in this, and he's got 3 sales so far. Okay, I think that's as many books as he sold. Now, if you look at another book, Harry Potter, there's how many users do you think have bought that? Like, whoa, like that's going to be way too many elements in an array. Way too many. So what you may want to do if you leverage the outlier pattern is leverage the customers purchased, but don't store every single array element. Store them in a separate collection, okay? And then include a flag attribute called has extras. This is, again, up to you. It's arbitrary what you call it, but your application will know that if you have has extras equal to true, then you can go get the additional users. So in this way, using the outlier pattern, we can have multiple data types supported, and the application itself can get all of the key details that it needs efficiently. And when you want to do some extended analytics, for example, you know where to go to get that data. This is the outlier pattern. You can read further on building with patterns. So on the MongoDB blog, Daniel Kopal and Ken Alger, 2 of my favorite people, wrote about all of these patterns, and the outlier pattern is documented there. Now, in the same way that there are patterns for good, there are patterns for bad. There are anti-patterns. So common design anti-patterns. Let's avoid storing massive arrays. Now, we kind of touched on this with the outlier pattern, but you never want to store unbounded arrays, okay? Never want to knowingly create, knowingly create an array element in your document model where you don't know for sure the number of elements that are going to be stored in that array. Okay, you never want to like knowingly avoid planning for the maximum number of array elements, because if your application doesn't plan for this, you could quite possibly end up with a massive number of array elements blowing out your array and causing your application to explode. The other thing is massive numbers of collections. Now, we get this quite often when folks come to us from the relational world and they simply convert tables to collections. They want to convert their relational application to MongoDB. They simply say, well, collections sort of look like tables. Why don't I just convert all my collections to tables? You will most assuredly have poor performance if you do that. Okay, storing a massive number of collections in your database is not a good idea. Unnecessary indexes. Why is this a bad thing? Why is creating an index a bad thing? Indexes are good, right? They lead for you to be able to access the data more swiftly. Well, if you create indexes where you don't need them, then every time you write data, your index must be rebuilt. You must add to your index too. That's going to impact your performance. So you only want to have indexes that your application is going to use efficiently. The great thing about this is that we have something called the Schema Advisor built right into MongoDB Atlas. And if you create an index that you're not using, it's going to know it and it's going to let you know. It's going to let you know, hey, dummy, you created an index that you're not even using ever. The next anti-pattern is bloated documents. Bloated documents are documents that have way too much data. Like you've got all of the data for your application in a single document, and you're not referencing the elements in that data, all of the elements at the same time. Storing large amounts of data together in a document when you're not frequently accessing them together. Another anti-pattern is separating data that is accessed together. So you've been too aggressive in your referencing models. Okay, you're referencing where you should be embedding. This is an anti-pattern. You want to avoid that. Okay, so let's look at the bloated documents anti-pattern. Okay, so in this case, we've got a document where we've got some key details for the application, for the movies application. Okay, we've got the year. We're going to reference that. Come on, my mouse is going crazy. We've got the year. We've got the title. These are going to be accessed every single time that we pull up data about this particular movie. However, if you look at some of these, this appears to be bloated. We've got facts about the movie. Now, we're not very often going to be displaying facts about the movie. So this is an opportunity for us to slim down our document model and move these facts to a separate collection. This way, it models the way that our users are accessing the data in the application. So for example, we've got a primary screen with some of the key details, year, title, plot. And maybe if they click a detail, if they click and get more detail, then and only then do we display the facts about the movie. That is an opportunity for us to leverage and avoid the bloated documents anti-pattern. So that is basically the opposite mantra, which is data that will not be accessed together should not be stored together. Okay, so it's the kind of the swing side, the opposite side of the coin for our mantra. Now, the last thing that I want to touch on is the Schema Advisor in MongoDB Atlas. Okay, this is going to give you hints about how you've done when you create your data model. When you model your data and your application begins accessing the data, your users are slamming the data, it's day 2, 3, day 30 of your application launch. The Schema Advisor is keeping track, it's keeping tabs on the efficiency of the index structures that you've created, and it's going to give you suggestions, okay? It's going to tell you if you need to create indexes that don't exist. If your application is accessing data and it's doing what we referred to before as collection scans, that's bad. Collection scans are bad. That's where the database itself must access every single document in the collection in order to return the data that you need for your application to display. So we want to avoid collection scans. The Schema Advisor is going to look at those and tell you about them. It's going to tell you when you have unbounded arrays. It's going to tell you about large documents, if you've got super large documents that you should reduce the size of. And it's going to tell you about reducing dollar lookup. Do you remember I made a very quick reference to dollar lookup? Dollar lookup is it's kind of the MongoDB version of join. It's like a left outer join where we join data together from multiple collections. obviously that's a costly operation because it's multiple reads on disk. We want to avoid that where possible. And the Schema Advisor is going to know. It's going to give you those details. So you can find the Schema Advisor, or it's also known as the Performance Advisor, in the MongoDB Atlas cluster display. It's one of the tabs there. You can click on that, get those details, and it's going to tell you create indexes, drop indexes, improve indexes. With that, I want to bring you to our quiz. Let's blow through this. Hey, stay tuned. We're going to have the survey coming up, and I really want your help here. I need your help, so stick around for the survey. Quiz question 1: data that will be accessed together. A, should be normalized. B, okay, you guys know this. D, everybody's should be deleted. Oh, come on now. All right, so it should be stored together. Nice, you guys are doing well. What's the name of the MongoDB podcast? It is C, correct. MongoDB podcast. You can find it at mongodb.com/podcast. Like, subscribe, give us a comment. Would love that. Question 3, what happens to all the previous documents when you modify the data model in MongoDB? A, right, nothing. Polymorphism rocks. And lastly, what is the default preference for data modeling in MongoDB? You guys are awesome. A, embedding. Data that is accessed together should be stored together. Here are some additional references. You guys are going to get this as a part of the email that goes out on Friday. With that, let's take a look at some of the questions that we got. And please remember to respond to the survey, which is going to come up. All right. So we need to get 95% on that survey. You guys got to stick around and do that survey. While we do that, how are we doing, Jesse?
Hey,
we got some questions.
We have 500 people and 48 questions.
Holy cow!
Are you ready?
Yes. Yeah. Let's do it. Do you want to go from the top? What do you want to do?
Yeah. We're gonna go from the top is the oldest. So let's start at the top, and I'm gonna give your voice a break. So just take a minute. I'll go through a couple. You just let me know when you're ready to speak again.
All right. Thank you, Jesse.
All right, no problem. All right. So oldest question is, why do we need MongoDB? Okay.
Great question.
So wait, this is the year 2022, right, Mike?
It is, yes.
It is. Okay, it's 2022. Okay, so MongoDB is a modern way of storing data that is fast and efficient, right? So these other ones, they were created in the 60s, 70s, right? They're not modern, right? I don't know. That's my answer to it.
Okay, we got that.
All right, get that out of the way. All right, next one. I'm using MongoDB and I have a replica set that has 3 members, 1 primary, 2 secondary. I recently got an error